Okay, this is the P2 paper from January 2023. It's question number 2, and as you can see by looking at it, this is a differentiation question. We're going to be finding stationary points, finding maximums, etc. And at the start here, we're going to be modelling with differentiation. So let's have a look and see what they've given us. Excuse me, they said they've got a brick in that shape there, a cuboid, x by 3x by h. It tells me that the volume of the brick is 972, and it says show the surface area of the brick is given by this formula here. So the surface area of this brick is going to be this area at the front, and there's 2 of those. It's going to be this area on the top, and again there's 2 of those, there's one at the bottom there as well. And it's also going to be this area at the side here multiplied by 2. I'm not going to focus on it too much, but what I am going to do is work out that if I'm working out any of these, say for example this area, it's going to be 3x times h. So that means I'm going to have h in my answer there, but I don't have a h. So what I need to do is to see how can I get rid of the h out of my function, and it's using this idea that that's the volume. What I'll do is I'll work out the volume in terms of an algebraic expression. I'll say that's equal to 972, and then I want to try and get h so I can put it into my surface area formula. Let's go ahead and do all that. Then I've said a lot. Let's actually explain what we're going to be doing. So first of all, the volume of this box is just length times width times height. So that's x times 3x times h, or in other words, 3x squared h. But we also know that the volume is 972. So that's equal to 972, and the whole point about doing that was so that I could get h in terms of x here. So h is 972 divided by 3x squared. So what I'll do in a minute is put that in to my formula for my surface area. But let's work out what the surface area is going to be. And as we said, the surface area is 2 of those, 2 of those, and 2 at the top there. So if we're going to be doing that, that's going to be, I'll do it really slowly, surface area is going to be x times h, 2 of them, 3x squared, 2 of them, and 3xh. 2 of them. Obviously I could do that a little bit quicker, but let's just take a time to work that out. So what's that going to work out? That's 2xh plus 6x squared plus 6xh. Oh, sorry, the xh's are the same as well, isn't it? So that's even easier. It's 8xh plus 6x squared, but I now know that this h can go into that formula there, so the function I'll have won't have any h's in, and hopefully it's going to be exactly what they've asked me to do. So it's 8x times 972 all over 3x squared plus 6x squared, and that works out to be 2592 over x plus 6x squared, and that's what we were trying to get. So excellent, that first part. Now guys, if you can't do that, there's always going to be this style of question. If you can't do that bit, there's still loads of marks here that you can get. Use this function now and find ds by dx, find the stationary value, find maximums and minimums. So if you can't manage to do the first part on your actual exam, that doesn't stop you from still being able to do a lot of damage in terms of marks here by going on and doing part B, C, etc. But hopefully part A makes sense to you. So once we've got that, then S is equal to 2592 over x. Well, if I'm going to differentiate it, I'm going to write that as x to the minus 1 there, plus 6x squared, and then we just want to find ds by dx. So ds by dx, multiply by the power, take 1 off the power, so that's going to be minus 2592 x to the minus 2, plus 12x. So yeah, that's it. That's nice and straightforward for ds by dx. What did they then ask me? They then said, can we find value of x for which s is stationary? So at stationary points, ds by dx is equal to 0. So let's tell the examiner that I know that. At stationary points, ds by dx equals 0. So that means that this function is going to be equal to 0. So minus 2592. You can say x to the minus 2. I may as well tidy it up to over x squared plus 12x equals 0. It's really important that you know all your rules about indices. They're used a lot in the P2 questions with differentiation and integration and what have you. Yeah, so let's tidy this up and take the minus 2592 over to the other side. Gosh, trying to get my handwriting sorted out. Then multiply it by the x squared. We're going to get 12x cubed equals 2592. So I'm going to get x cubed works out to be equal to 2592 divided by 12. That looks familiar to me, 216. Cube root 216 works out that x works out to be equal to 6, which is a lovely, neat answer and makes me think that I've got it right. Now, what did I want to do? Yeah, just make sure you've answered the question. I wanted to find the value of x for which it's stationary, not the actual stationary point itself. So that's fine. They could have asked me for more information than that. Now they've said for part D, find d2s by dx2. I'm going to have to differentiate again, and hence show that the value part in C is a minimum. Well, when I second differentiate, if the second differential, if the d2s by dx squared, if that is a maximum, if that is a positive, then it's a minimum, and if that works out to be a negative, then it's a maximum. So let's do all that. I'll do it over here. So part D. Let's find D2 first. So what was ds? ds by dx was minus 2592 x to the minus 2 plus 12x. So when we're differentiating again with respect to x, same rule, multiply by the power, take one off the power, so multiply by minus 3 gives me 5184. Multiply by minus 2, multiply by the power, take one off the power, that's where I got my minus 3 from, plus, and then we know what the differential of 12x is, it's 12. So we're talking about at the point x equals 6. So at x equals 6, d2s by dx2 works out to be 5184, 6 to the minus 3 plus 12. And I don't even work out the value, I say which is positive. You can work out the value if you want to, I'm just not saying it. If it's positive, therefore minimum value. Okay, if it had been negative, then it would have been a maximum. Okay, what does part E say? There's one last part to this question. Hence, find the minimum surface area of the brick. So the minimum surface area of the brick then is at that point, subbing in to the original formula. So 2592 over x plus 6x squared, and we know that's a minimum when x is equal to 6. So plus 6 lots of 6 squared, and then working out whatever that works out to be. Apparently it's 648, and I think the unit is centimetres squared for that one. Yeah, everything was in centimetres, so centimetres squared. Yeah, so not too bad. The first part of that question, in terms of working out the formula, was absolutely doable for some of you. And even if not, remember what I said about doing parts B, C, D, E, because that's where most of the work, where most of the marks are. Right, hopefully that will make sense to you.